This is a quick session on how to produce a small plot. I thought I'd also combine this with a little bit of a tutorial on how to load data quite efficiently into R. So you will have a session that looks a little bit like this, completely blank. We can look down here and see that our home directory, or the directory that it's going to be searching for files, is in your home directory. It might be in your C drive, but it's not pointing to any directory yet. Up here is all the data that's sitting in our environment, and it's empty at the moment. And I've opened up a new script here. If you want to, if this hasn't appeared for you yet, click File, New File, R Script, and one of these will appear. So there are a few things we need to get started with. The first is to load the libraries that we'll use for this short tutorial. The two libraries that we'll use are called dplyr and ggplot2. If you haven't already downloaded these two libraries, you'll need to download them. Go to Tools, Install Packages, and then you can search for those two libraries here. So dplyr, for instance, and you should be able to click Install, and it'll download it and install it and the dependencies. Okay, so if I do, with my cursor on that line, I can press Control or Command Enter, and what it will do is load those libraries. Each of those libraries contains a group of functions that we'll use in this tutorial. Next, we have to read our data, which comes from the PennWorld table. So I'm going to create something a little bit like a spreadsheet, a data frame, PWT for PennWorld table. When I run this next line of code, which goes and reads the CSV file, it will create an object called PWT, which will live in my environment. And that's like a spreadsheet. Okay? This arrow here is R's assignment character. I'm going to use the command read.csv to read this file. And I use quotes, single or double, doesn't matter, and press tab once I've opened that. When I press tab, it will allow me to search for where I've saved that file. Alternatively, I could set a working directory, and I find this a little bit easier. So I've saved that file in Documents, and then the ECO3EGS folder, and PWT21. You may have saved it as something else. So press Command Enter or Control Enter, and you'll see it's appeared over here. I've now got this object called PWT. Click on that, and it contains all of my countries, a whole bunch of economic time series for each of those countries. So the next step is to create the three dependent variables, or there's a dependent variable that we're interested in, which is the output per worker relative to the United States in 2010. And we also want the population growth rate and the average investment over the period 1985 to 2010. So I'm going to create a new object called pwt.ss, SS for subset, and this takes as its base pwt, and we're going to use this pipe character which comes out of the dplyr library. This pipe character takes whatever is on the left hand side and puts it into the function on the right hand side. And we're going to use the function filter. Filter, if you look over here, there are a whole bunch of rows for years that we're not interested in. I want to get rid of all of those years, so we get up to 2010, and then it starts back at 950 again. So I want to subset this so that we only have the rows from 1985 through to 2010. So I do that by saying the column is called year. I can get a column listing by just pressing tab inside here and scroll down to year. I want it greater than or equal to 1985. And I want year to be less than or equal to 2010. Okay? There is also a command called between, in which I could say between year 1985 2010, if you don't want to use the greater than and less than characters. This command here simply returns greater than and less than. Okay, so Now what this has done is taken PWT and subset that so that we've only got our year between 1985 and 2010 inclusive. If I put a pipe here at the end of a line and press return, it will have indented. That's just to remind you that that it's expecting something else, because it's going to pipe this, whatever this is here, into the next function. Next function that we're going to use is called summarize. Oh, sorry, group by first. So the command group by takes the data set that you're giving it. In this case, it will be a data set that is subset between 1985 and 2010. And we want to split that into multiple data sets. We want to split it by country. Now the country column here is called ISO code, the International Standard Organization code of each country. So we're going to split this data set into lots of small data sets. I then want to summarize, and we can use Australian spelling because the guy who wrote this is a Kiwi. We can summarize each of those chunks of code, each of those chunks of data. So we've got now, of the 100 odd countries in this data set, one block of code, one block of data for each of those countries. Now I want to generate 3 columns for each of these countries. The first one is the population growth rate, N, and for no other reason than it's quite easy, I want that to be the continuous compounding population growth rate. A very easy way of doing that is to take the log of the last population divided by the first population divided by number of observations, which is N. In the Slack channel, I'll go through the derivation of why that works. The next one is that we want the average investment, so I'm going to create a column called INV, which is the mean of KI, which is the real investment as a proportion of GDP. And the third column I want is Y. Y here is the, we can go into, I think I've got this already launched in Excel. Okay, so you can have a look at the variable names in this file, pwt vars for web, and you'll see this is purchasing power parity converted GDP per capita relative to the United States GK method at current prices. So I'm just going to use Y there. Oh. Beautiful. Y is equal to the last of Y. And the last of Y will be the 2010 value because we've subset this appropriately. So if I run this whole thing, what it will give me is our Penworld table. We filtered it between 1985 and 2010 values. I've grouped it for each of those countries, and for each of those countries I've summarized their statistics. I have one column called N, which is the population growth rate over the period, the continuous compounding population growth rate. I've got the average investment rate, and I've got the 2010 GDP per person relative to the United States. So we've gone from 11,590 observations down to the 190 countries that are in here. Okay, you'll notice that a lot of them have missing values for investment. That is the only one they've got missing values for. So what you may want to do is come back here and add one more, which is filter, exclamation mark, is NA in. Now, what this tells you, this function here, is you give it a column name in here, which is inv, and it will give a column of trues and falses. And it's true if it is NA. So, for instance, if I say is NA, it's true. If I say is NA 5, that's false. Okay, if I say not is NA 5, that's true. Okay, so we'll take whatever the opposite of, so not is NA, that's false. using this command here, filter not is NA, just returns all of the rows in this construction here for which investment is not NA. Okay, so let's run that. Go down to 159 countries. Very nice. Okay, so I want to do a few plots of this data. The easiest way, if you want a very, very quick exploration to see where the correlations are, is simply call plot pwt.ss. Now, if you look at pwt.ss, the first column is the ISO code. I don't want to plot that, so I can simply ask it to remove this by saying not the first column, which is I use a -1. PWS, sorry, I misnamed this. And down here we'll have an n-way plot. So we can look at how GDP per capita correlates with investment and population growth rate. We can look at how investment correlates with population growth rate. It's quite an easy data exploration tool. The second way of doing this is to use ggplot, which produces more handsome plots. So I take pwt.ss and I pipe that into a ggplot. ggplot requires that I use this aesthetics command in here, which says I need to have an x value at the very minimum. Here that will be my investment. And if let's say I just want a histogram to get an idea of the distribution of the investment across countries, first of all I say this, but if I just run this line here, nothing happens, it will complain. No layers in plot. I have to tell it what sort of plot it should make. And I do that by using a plus, go to the next line, and then geom, either histogram or geom bar, which represent very similar things. And here I have a histogram. So I can see there's one country over here investing 65% of its output. It's probably some oil country. We've got a bulk of countries here. We've got some countries that are investing almost nothing. But you can see most countries will invest between kind of 15 and 25% of their GDP each year. If I want something a little bit smoother, I could say geom density, and this returns a kernel density estimate, which is basically as though you made a histogram but made the buckets as small as possible, more or less. So that's an easy way of doing things. Now we can also make scatter plots. So I could be interested in having investment along the x-axis and population growth n on the y-axis. Now, of course, I can't ask geom density because it's like doesn't know what to do with y. I say geom point, which is the ggplot code for a scatter plot. And I look at this and I think there's not a great deal of a relationship between these. I should probably scale these in the same orders of magnitude. So there's a quick introduction to loading your libraries, reading some data, summarizing your data for each country, and generating a plot. I hope that helps you with this week's homework.